All right. So we're just gonna. Why don't you just go down the lines? I've worked so much with you all, but just share, your role in the company, and then for the first question, maybe a little bit about. We've heard a lot since the beginning keynote about the need to pivot and react to what's happening in the AI space. So please introduce yourself, and then maybe a pivot that you've had to make in your company roadmap in, say, the last 12, 18 months. You gonna start us up, Mohan?
Okay.
Yeah.
My name is Mohan Kalkunte. I'm the VP of Architecture at Broadcom in the switching group. So this is the group that does the switches. Basically, we make the chips like the Tomahawk line and the Jericho line. So one of the things that is, taken by, I should say, bull by the horn, so to speak, is uh, things have evolved very fast, right? What used to be, um, you know, um, training centric workload, things have evolved so fast right now. We're talking about distributed inference, you're talking about reasoning models, you're talking about bandwidth going much higher, you're talking about bigger and bigger data centers, right? So as a result of all of these things, right, so what does that mean? So the network becomes very critical, it's very important. So you have to make all these things work together. So so three things that comes to what we had to do in order to address this. One is the scale out, right? You all have heard, in fact, Pradeep's talk as well. You heard about scale out. So here's where that we see our customers, they want to build bigger data centers. So we introduced a device called Tomahawk 6C, the first 100 terabit device. So basically what was possible to do such large clusters with 3 tier, now you can do it with 2 tiers. So that's one example. On the scale up side, there was always a notion that you cannot build low latency Ethernet switch. So we recently announced Tomahawk Ultra, 250 nanoseconds of latency, high bandwidth, lots of features like link layer retry, credit-based flow control, and so on. So that's something that we want to enable for the scale-up, deployment. And lastly, we also heard from Gaia's talk this morning about, connecting over long distances, multiple data centers, and this is where our the Jericho line of switches with deep packet buffers, with its congestion control and hyperport and so on, is. So in essence, what we see is that with all the requirements, you need high bandwidth, high radix, low latency, and our approach has been is that it has to be optimized for these different segments going forward. So that's what we have pivoted to, and we'll continue to work on those lines.
Yeah, I think we brought a lot of those, and I'm sure other folks brought those to you very quickly.
Yeah.
So, Rakesh?
Fantastic. Hi, everybody. My name is Rakesh Chopra. I'm an SVP and fellow at Cisco, and I work on hardware architecture, sort of spanning silicon systems and optics. So I completely agree with everything you say, but I'll bring maybe just another flavor to the situation. The thing I found maybe surprising to me over the last year and a half, is what we're seeing happening in terms of models from an AI perspective. I think we're starting to see a notion that in some cases models are actually getting smaller rather than larger, which is frankly unexpected to me. The second thing is I think that this notion that we're creating models now which are trained and operate on very rich multimodal data, whether that's text, voice, or video. And finally, I think the third model change that I find interesting is the agentic notion that this entire concept of being able to sort of iterate and solve for things in sort of a multi-step process to, quote, reason, I find very interesting. And what taken together, I actually have started to rethink how new capabilities come from AI. And I really, actually, frankly, wasn't expecting that a year and a half ago. And I think it actually makes me wonder about whether this whole notion that we've had in the industry that the way to get new capabilities and new intelligence from AI is just endlessly scaling. And I'm starting to wonder whether we need to actually think about working a little bit smarter rather than harder. And to me, that creates sort of four interesting imperatives. One is, I think, that across the industry, we have to work together to sort of break down silos, both organizationally and technologically. And by the way, that's part of the reason I love this panel, because we've got a wide group of people here. Two is, I think, as some AI models shrink, we'll see a move towards the edge of AI, which is, again, a new change. And that will mean that we need to embed AI capabilities into edge devices, but also sort of backhaul that to the data center. And we'll need a very efficient WAN network to be able to solve that. I think that the multimodal notion of models are actually going to exacerbate many of the discussions that we had earlier about needing very large, very efficient data center infrastructure. And finally, I think the agentic AI is going to cause us to have our networks have to be actually much smarter than they are today, and they'll need to be able to evolve with programmability to deal with varying workloads over time.
Exactly. Yeah, fantastic. Thanks. Krishna?
Hi. Hello, everybody. First of all, thank you, Meta, for inviting us and organizing such an awesome event. I was surprised to see the number of people. My name is Krishna Doddapaneni. I lead the software efforts of networking business inside AMD. I would add to what Rakesh and Mohan said. So what surprised me over the last year is basically the inference capabilities. We're building inference models, the reasoning and test time compute, how it made unpredictably expensive to do these models. So I think, where we have to go towards, there are a lot of papers on it and industry is working towards is how we can get to distributed inference with, time to compute, time to test compute, TTC optimal models, and that requires changes in the models, changes in the algorithms, and changes in the infrastructure. And it could come back to even networking, because if you talk about 9 months before, we were not talking about in the networking for distributed inference, we're not talking about tensor parallelism, expert parallelism, the network burstiness, all those problems, it's also coming back to inference. So that's where we need to work as an industry collectively, how we can solve these problems.
Thanks. Yuval?
Hi, I'm Yuval Degani from Nvidia. I lead hyperscale AI networking group in the US. What we do is we help all of our hyperscale customers and partners to build the largest AI factories out there. So that's very exciting, especially for the last couple of years. If I have to recall one thing that was a big surprise to me and prompted a pivot, across the company, across multiple facets, not only networking, I would say low latency as a top priority. With the arrival of agentic models, basically I'm doubling down on a lot of things that were said here, which I totally agree with. So with agentic models, reasoning, a lot of system-to-system interaction, we're kind of moving away from a point where the limit that needs to be used as a target is the actual human limit of consumption for a query. And now actually we have models interacting with each other a lot more frequently to produce a result that makes sense to the user. So this reasoning in the back end, those limit for the user is actually the human limit is being put away from that picture. And now low latency plays a major role in serving a query. So that would be with a mixture of experts or with multi-models like was discussed here. And now this is a top requirement that sits on top of having to build very large scale clusters. So, if we look back a couple years, 50K GPUs, 100K, 200K, and now even beyond that. So throughput is not king anymore. So there are multiple things that need to be addressed here when you design a fabric. So now it's this equation of how do we still maintain maximum throughput, because there's also a lot of data flowing around, videos, images, and things like that, but also low latency, so there could be quick iterations within the model itself, but also in front of the user. And of course, power. How does power sit with all of this together and still let us design an efficient data center?
Great, thanks. And then Rajiv.
Hey everyone, my name is Rajiv Krishnamurthy. I work for Meta in the infra group. I support the host networking team. So in terms of what surprised Meta, I guess I'll wear the operator's hat. We work very closely with all the folks on the panel here, and I echo everything that they say. But the big thing that has been surprising for us is actually, was covered by Gaia a bit in the morning session. It's, the pace and the rate of change. That has, it cuts across the entire stack all the way from the way the applications are being built, the models are evolving, how we are building our rack systems, how we are building the data centers, how we are building our WAN. So that, we are used to moving fast, but I think the rate of change and how this industry is evolving has definitely been something that is very surprising for us.
Yeah, I think that was a theme, and thank you all for hearing for introducing and covering that. I think that, you can hear the themes. Like so much has changed, so much we've learned over the last 12, 18 months. Pretty radical changes to the models and to the where you want to focus and optimize. So, thank you all for that. Next question I wanted to go over was another thing we covered this morning. Gaia did was in terms of optionality, right? We Meta as a large operator, we want to work with multiple companies, figure out what's the best solutions, but also work with many different options. Hence, we work with all of you all. How do you? Maybe we'll kind of go sort of reverse order, coming back. But I'll let Rajiv wrap it up after. We'll go this way. So Yuval, can you talk about what your thoughts are on working with the ecosystem?
Sure. Yeah. So, of course, as NVIDIA, we ship a vertical system that, is across software and hardware and integrates very well together. And this is what we think brings the most value to our customers. But we realize and understand that there's a need for customization. And the way that we address that is by effectively offering the same parts of that systems a la carte, if you will. So you can pick up a GPU, you can pick up a switch and a NIC. One good example is what we do with Scale Up with NVLink Fusion. So you can pick up NVLink outside of a traditional NVIDIA system and make it your own. Another good example is Scale Out in the sense of for a NIC as a product, we have an SDK that is open for download for everyone, which you can basically design your own fabric. You can design your own virtualization, overlay networks, programmable congestion control, and basically make it your own for your own needs and customizations. And this is a practice that we're following across all of our product line, across all of the products that we ship, and we intend to continue to do so. It's very common for us at NVIDIA to look at this from the perspective of we not only strive to ship the best system and platform from a vertical perspective, but we also strive to ship the best product in each product category. And the way that we stand behind this is by addressing each one also individually with its own ecosystem.
Got it. How about you, Krishna?
Yeah, so AMD has an open philosophy of supporting open systems and not having vendor lock-in. If you have, for example, if you look at our current GPUs, whether it's MI 300, 325, 355, we ship them with AMD CPUs and AMD NICs, but there's also support and deployments. We have non-AMD CPUs and non-AMD NICs. We'll continue the same thing for future AMD GPUs. Also, the other thing I would say is to enhance this, optionality and openness, we need to work on standards. AMD some of the partners here have been working on UEC, where we define, scale out networks, how you build scale out networks, like a million GPU cluster. We define, transport layer, how you do load balancing, how you do congestion management. Earlier, Pradeep was talking about how you link level retry, all those things. Then people have an option to swap out components more openly through standards. And similarly, we're also defining for scale-up fabric called UOL, where when you want to take a memory fabric on the node, we want to extend it to a fabric. We're working with open standards. What do you do in the GPU? How do you build switches? And working with partners to build this ecosystem that gives more choice for customers like Meta.
Yeah. Okay. So that was an interesting point, right? So I kind of went in this direction because the two of you all, your companies, in terms of manufacturing, you're making GPU systems, obviously, for general consumption. But then if we go down here for Cisco and Broadcom, you all don't. So the question changes a little bit here because it's a little bit picking up on Krishna's point about the standards, right? But then also Pradeep's point about, well, we may not have the standards right away, maybe too far out in the future. How do we kind of drive the standards? So maybe can you all talk about that? How do you provide your networking components, whether across scale up, out, or WAN, all the way to the edge, right? How do you do that for AI pre-standards in a way?
Yeah, it's a great question. So maybe it goes without saying, but I think Cisco has always been and continues to be a huge proponent of open standards. I think there is a little bit of undercurrent in the industry around whether standards either accelerates or stifles innovation. And my personal view, and I think the view of many folks at Cisco and probably many of the folks on this panel, is that actually open standards is actually fundamental in terms of sort of solving highly complex multidisciplinary problems. And I think what makes them interesting is that companies bring in their own expertise, but companies can still sort of innovate in their own sort of implementation of those standards. And so you still get differentiation in the industry, but interoperability. And if I think about where that has sort of been exemplified the most in my mind, the case that I come up with is the internet. Imagine if we had all sort of gone at it ourselves and we hadn't standardized the internet. It would be complete and utter chaos, right? But because we actually standardized on IP and the internet, what's ended up happening is we've unlocked a huge, huge innovation potential. And more recently, I think what we're seeing is what was discussed earlier was this notion around UEC and AI for scale-out networking. I think the industry really came together very well to help define how to use Ethernet in that infrastructure. And what we've ended with is exceptional performance with multi-tenancy and massive scalability. So that to me is a success story. I think maybe, Omar, what you're picking at a little bit here is the question about scale-up networking, which is the industry isn't yet quite gelled, let's just say, from a standards perspective. And I will admit that I think scale-up networking actually is harder than scale-out networking in many ways because there's a much tighter coupling between the workload, the GPU, and the network. But actually, I think that is the reason that we as an industry need to work together. So bringing together, much like we did in UEC, the GPU vendors, the hyperscalers, the switch vendors, the broad ecosystem of AI workload developers, and bring that stuff all together, I think is really important. In the short term, I think we're all working together in sort of, backdoor style discussions to try and bring things together. But I think what we have to get to is we have to come up with sort of that broad ecosystem. And the way I think about it is optionality at the scale of AI isn't a desire. I think it's actually fundamental.
Great. All right, Mohan.
Yeah, so a couple of things I'm going to pick on you for it.
Please do, pick away.
Let me get to that in a minute. So first of all, we're in the business of interconnects, right? This space moving so fast, you can't wait for standards to be developed before you develop products. So you have to have, products come out as soon as possible. So for instance, right, we came out with Tomahawk 5 back in 2023. Now we have come out with Tomahawk 6. Now, in terms of are there capabilities in these devices that are quote unquote not standardized? Yes, there are. But this is how it starts. Any innovation, any kind of new features, you kind of put that out in your device, and then you see how you can drive the ecosystem, because you just don't want to be the only guy out there with this differentiating features. You want the entire ecosystems, you want your partners, you want your software partners, everyone else collectively working towards that to enable that stuff. So let me give you a couple of examples. For instance, in Tomahawk 6 and Tomahawk 5, we have this capability called packet trimming. Now, what does that really mean? That means when the packet experiences congestion, you truncate the packet, you send just the header to the receiver, so the receiver can send back notification to the sender so that it can happen pretty fast, right? So this was not a standard feature, but this is something that we have it in our device, and we are, it is part of the UAC 1.0 right now. So that's an example. You come out fast and you try to standardize so that you can bring the rest of the system along. Another example I'll give you is what we call as congestion signaling. This is the ability to probe through the network where the bottlenecks are, and you inform, your host in this case. So that's another thing that the standardization is in progress. So yes, it's a balance between time to market and having the capability and standardization. Now, I'm not saying that this is something that you have to do every time, but wherever standards are available, we should go ahead. Standards are good. We are all for it. In fact, Broadcom is also part of the UEC, Ultra Ethernet Consortium. So to your point earlier, you said scale up is harder. I disagree on that one. Scale up is simpler. We have, so towards that end, we are talking about scale up Ethernet today. We have number of hyperscalers, our customers, because Broadcom is also in the business of doing ASICs, right? So we have a number of hyperscalers that are building scale up on Ethernet, right? So it is possible, and one of the things to address your standardization stuff, right? So this is something that we are not holding back. Scale up Ethernet is a specification that we put out. We contributed that to OCP, and we are more than happy. It's not our IP. We kind of completely give it away so that people can go and develop this.
So Rakesh, I'll give you a couple minutes
Awesome.
to a little bit of time for the.
So a few thoughts. So actually, I completely agree with some of the things you said there, which is one of the dynamics that's happening in the industry is as everything is moving at an incredible pace of AI, whatever you think the answer is today, a year from now is probably not the right answer. And that makes a very interesting dynamic in the industry that, we've moved quickly as an industry for a while, but AI is absolutely poured a gasoline on top of this fire. And to me, actually, that's part of the reason I think about having a programmable infrastructure, whether it's for future AI models or for features like packet trimming or UEC that were never created when we came out with our silicon infrastructure. Having that capability, whether it's telemetry or whether it's congestion notification, that allows you to sort of evolve. And so I completely agree that you can't wait for complete standardization. And the way we think about that is having programmability allows you to implement those pre-standards while they're evolving and adjust over time. In terms of the scale-up question, I 100% agree that actually you can build scale-up networks with Ethernet, whether that's an optimized Ethernet implementation or pure Ethernet. I think there's lots of work going on in the industry, and lots of different customers have different paths that they're investigating. I think what we all need to work through as an industry is trying to figure out how to get the optimal end-to-end implementation across the workloads, the GPU, the switch, the interconnect. And that's why I think it's just one level harder than scale out, where it's a looser coupling, than scale up, which I think is a tighter coupling.
Okay,
So now I'll let. Go ahead.
One thing I would
Got
want to
something
add to
quick.
Rakesh thing is that, the programmability, we also as AMD, we completely believe in it, because the UEC standard just came out, right? But we are doing NICs, and take ASICs taking time. It doesn't come out in like a year and a half, right? So we also believe that. So what we did is we built a programmable infrastructure with our NICs, with our current NICs and future NICs. You can do any transport. We are calling it pre-UEC, and then when UEC comes out, we'll implement the UEC version. I think that's the right way to think about this problem.
So Rajiv, Rajiv, you want to have the last word on this
Sure.
topic here for us?
I echo every single thing that has been said on this panel. I know we had people approaching it from different perspectives. At the end of the day, when we look at it, why Meta believes a lot in open source, and this has been something that we've been from the very beginning focused on. OCP was a good idea that we decided to focus on, because we wanted to get the industry and the ecosystem together. I think the main theme here is change is constant and the rate of change is increasing. So at this point in time, having open communication with all of the vendors, getting together and trying to actually solve the real problem and moving forward is probably what will help us, make networking exciting again and solve the big problems that we want to solve together.
Yeah. I think, some of the themes I was hearing in terms of just, the sharing in an event like this and whether through OCP or other ones, we're just sharing the learnings because things are moving so fast, right? And actually just, you were reminding me about packet trimming or programmability. I remember, over the last 10 years, many of you all and folks out there, we were talking about, programming the network and having more flexibility. And a lot of those concepts, I remember in some of those earlier chips were like, why would you ever want to do that? Why would I program to do that? And it certainly wasn't a standard at the time, but now people are finding the use cases for it. So it's, so it may take a little while, for it to kind of percolate through. But it's great to see the experimentation in research, in startups, as well as within large companies like ours. Okay, we're gonna fast forward to sort of our last question for the audience here. A little bit different, right? So there's a lot of folks here from varied backgrounds. We have a number of folks early in their careers or just starting off their careers, mid-career, seasoned professionals. Quick advice on how you would say get engaged into this active AI, constant change area. You want to start there?
Yeah. So I think one of the things I would advise is, try to understand the AI workload. Follow the workload pattern. You have to study the models because these models are evolving so fast. We have all kinds of, we talked about earlier in the talks, we heard about different kinds of parallelisms. So the workload pattern constantly keeps changing. So that's number one. So my suggestion is that people really have to fundamentally understand this first.
I think that's for anywhere in your career. Coming right out of school, us at the other end of not coming out of school.
Right. Yeah. So that's the basic thing. Now, as a result of that, right, because in order to make all of these things work, you need to have networking, right? So then you figure out, or at least try to understand, where does the problem lie? It is from GPU to GPU. Is it in the software? Or is it in the hardware? So you try to distill and see where exactly those are. Yeah. Then you try to see, where exactly, what are the kinds of things that you can do in terms of communication stack or any software improvements, or are there hardware improvements that you can make? There are offloads that you can make. So so you have to distill the end-to-end problem into software and hardware kind of stuff.
Great.
And the third point here is, you have to keep, one of the things I think is really important is power. Power efficiency is also important. So see what needs to be integrated, what needs to be disaggregated kind of stuff. And lastly, I think, networking is not just about, moving packets. It's about looking at this problem holistically, compute, memory, access, all of this thing together. And if you can think, at the intersection of all of these things and understand this really, I think that will be a valuable skill going forward.
Definitely.
I don't think AI will be able to replace that.
Okay, there you go. You heard it here. So I'm going to come back to that, but later. All right, Rakesh.
So I actually agree with pretty much everything you said there. So I'm going to take a slightly different tact, which is I think what's fascinating about where we are as an industry is we've all heard from all of us and throughout the day just how quickly everything is moving. And it's moving on every vector simultaneously. So whatever your desire is in terms of engineering contribution, there's a place to be incredibly relevant in AI. And if I think about the previous epoch that we've had from a networking perspective, it was really what I'll call a software-defined networking, which really sort of drove that next pivot. But if you think about what's happening in AI right now, is we are talking about something that has the ability to move global economies and make and break companies at a very fundamental level. Like the opportunity here is huge. And so my advice to everybody is whatever aspect of engineering interests you, jump in, use AI actually as a tool to drive your innovations. Don't fight against it. It is there to be an accelerator for your innovation ideas. And have fun. Like, this is an amazing time to be an engineer. And what I actually find most fascinating, maybe, is that this is almost like the Super Bowl moment for engineers, right? Like, let's make it count.
Yeah, great, great. Krishna.
First of all, networking has never been this exciting in the last 2 years. Before, networking was like more of evolving thing. I mean, right now, I think today probably you heard a lot of conversations, scale up pods, scale out pods, there's hardware, software code design, the NICs are changing, CPUs are changing, GPUs are changing, switches are changing, we're putting in network compute. With so much rapid pace of innovation is going on, typically, I would advise to look at not how things are done and why things are done. And you go back to the first principles, and then I'm sure you'll get new ideas to innovate. And the other thing I think a little bit understated is that, actually when we were coming out of school, we didn't have this much access to information. I mean, we didn't have this events, and I mean, Meta puts blogs, everything is in YouTube, same thing with NSDI, same thing with, SIGCOM. The information that's available, if you really want to go and research and use to get inspired to build your own products, is available at fingertips. I would really encourage, because I saw a lot of new graduates outside, I would definitely encourage that, and that's a good habit to have.
So I will stick to something different, but the theme of the day, which is scale. So one of the things that I find very difficult to kind of, catch up on, let's say, experience gaps as an engineer, is how to deal with scale when scale shows up. Scale shows up when it's too late. So you design for it, you build for it, and then you deploy it. And then once it's deployed and you actually have scale, you have to rush and make your work and just get it out to production. You never have the time to actually sit and study it and understand it and experiment with it. And the way that you gain those skills is by doing it many times, and then you get the experience and the expertise. So one thing that I found to be very much overlooked is simulating scale, which is a very hard thing to basically achieve, but very often overlooked. So what I would recommend for the inexperienced network software or hardware engineer is to embrace simulation tools, be it in open source, experiment with different algorithms, get a feel for what it's like to see a network running at very large scale. What are the kind of issues that show up? That, I think, could be very much a catalyst in getting a very deep understanding of what it takes to scale a network and actually make it work efficiently in production. And then when we actually get to the point where things need to be delivered into production and there is no time, that expertise is already there, and those things can be achieved in a much faster pace and produce a better result. So basically, experiment, get a feel for it. I think there's nothing beats that in terms of filling in on an expertise gap.
Thank you.
Right. Awesome. I think I agree with all the suggestions that were given here, and just taking a different tack. Let's talk. I'd like to focus on behaviors, right? So, Omar, you mentioned folks early on in their career. I think your biggest strength is your curiosity, right? So if you can lean in on your curiosity, I think all the problems that you heard over here, also Krishna mentioned how to do it, right? How to go about solving it. I think that's probably your super strength. And my suggestion would be, just double down on your curiosity. That's what's going to make you successful. For folks that are in your mid-career or seasoned professionals, my suggestion would be, the problems have not changed. The tools, the technology, the way you go about solving them, basically the how you're going to solve it probably has changed. But you can lean in on your experience, the scars that you have on your back operating these large networks. I think you can basically lean in on that and help on, design and even come up with solutions and problems and double down on your experience. So that would be my suggestion.
Awesome. I am pumped up myself hearing all that. So, well, please help me thank. Thank you all for sharing your thoughts and experiences. Please help me thank everyone here.